Osmosis and diffusion. So osmosis and diffusion, two really important concepts for our cell's unit. This is basically how most of the waste gets out of a cell, moves across the plasma membrane out of a cell, and the water, glucose, ions, things the cell needs moves into the cell. So how it balances its external and internal environment. In a nutshell, diffusion you can observe when you drop some food coloring into a beaker of water, and you see over time it slowly spread out until the whole thing is kind of homogeneously purple. That's the key example of diffusion. So understanding how diffusion works and being able to predict the fusion's effect on a cell, which way different substances will diffuse, is extremely important for here in AP Bio. So this macroscopic picture of diffusion, when we look at this spreading out of food coloring in water or perfume in a room, the smell spreads out. Really, to understand it, we have to look at the small scale. So what's happening at the smallest scale? Well, in the beaker of water, if we pretend that each of these is an atom of food coloring, each of these purple dots, an atom or a molecule of food coloring, they're moving around kind of in random motion. So you can see that the arrows of where they're moving are kind of random. So the particles, the atoms, have energy, and so they're moving around completely randomly, completely bouncing off each other, off the container sides. And the more energy that these particles have, they end up moving faster. So if you heat the water up in the diffusion example from the first slide, the food coloring in water, if you heat it up, these particles will start moving around faster. So random motion caused by the energy each particle has. When these atoms collide, or these molecules collide with each other, they bounce off each other in different directions that can be described by their speed and their direction. So collisions cause particles of the food coloring to bounce off each other in different directions. When there are more atoms or molecules of food coloring in a given amount of space, more collisions with each other happen than if there were only a few atoms. So for example, down here, if these are each, the green and the blue atoms of food coloring, if there's not a very high concentration of that food coloring in water, these collisions won't happen very frequently. If there are a lot of those food coloring molecules in a given amount of space, those collisions and those bouncing off reactions will happen a lot more. So there's more collisions between particles and molecules moving around randomly in a concentrated solution versus an unconcentrated solution. Collisions cause these atoms to spread out from each other. So if two atoms hit each other, they're going to spread out. So the more collisions there are, the more that these molecules will tend to move away from each other. So here, when they're not very concentrated, a lot of these molecules can take up the same amount of space without really dispersing, because there's not very many collisions happening to bounce them off of each other to spread out. Over here, lots of collisions, that means they're going to be spread out, because as soon as they hit each other again, they're going to move away from each other. They're going to hit and bounce off in the opposite direction. So lots of collisions over here. This will become more spread out. Not very many collisions over here. Won't become as spread out. Low concentrations, not colliding. High concentrations, colliding very often. And like we said, if we would heat up this water, this beaker of water, and all of a sudden these molecules are moving around faster, there are going to be more collisions. It's going to spread out faster than if it was colder. Not as much energy, less collision. So temperature, heat, speeds up diffusion. So in a nutshell, diffusion is just that, the movement of a substance from an area where it is highly concentrated to an area where its concentration is low. That's because on the last page, these molecules are going to tend to spread out from areas where they're hitting each other a lot and being deflected to areas where there's not a lot of other molecules to run into. That's what causes diffusion, the movement of substance from a high concentration to low concentration. It happens spontaneously, which means it does not take any energy. That's why they call it passive transport. Transporting moving molecules and atoms from one place to the other without taking any energy. And it's based on, like we said, the idea that when a substance is concentrated, more collisions will occur, and those collisions will push the particles away from each other or spread them out. So we call the direction the particles move from high concentration to low concentration the concentration gradient. So the gradient is just the direction from high to low concentration, the direction. So this was high, and this was low concentration of a given substance. This arrow would show me the gradient. For example, if I want to show you an example, this happening, I'm going to go to this website. Here we have concentration of yellow molecules. Here we have a concentration of blue molecules. They're going to start moving around randomly when I click play. They start colliding with their own molecules very frequently at the beginning because they're very concentrated over here on the right and the left. And over time, you'll see them spread out as those collisions become less frequent. So, let's reset it. Start off, high concentration, one over here, low concentration of the other over here. Those collisions amongst light colors will be the most common to start out with. So it'll spread the colors out to the other side. Once they become more distributed, the collisions with light colors will be just as common as the collisions between different colors. So the diffusion will stop. You can see as they spread out, as collisions between blue and yellow become more frequent, the dispersion ceases. So that is what is creating diffusion. Just like if I drop a lump of sugar in a beaker, those collisions between sugar molecules will become really frequent right here at the surface, so they'll start spreading out until it's kind of equally distributed. Those collisions make it equally distributed. But in cells, we have a membrane. In cells, we have our plasma membrane. How does that affect diffusion? Well, small particles like oxygen, like carbon dioxide, and less polar molecules, non-polar molecules, can easily diffuse through the plasma membrane. So like if you're breathing in, you're getting oxygen through your blood system, it's going to diffuse from your bloodstream into the cells because it's very concentrated in your bloodstream, not so concentrated in the cell. It'll naturally diffuse where there's less collisions inside of the cell until a concentration equilibrium is reached. So objects like oxygen, carbon dioxide, water can diffuse into and out of the cell without expending energy. Like we said, if we increase that temperature, we're going to increase the rate of diffusion. But how do we continually get oxygen into the cell? Well, your cell continually uses up oxygen, turns it to carbon dioxide. So using up that oxygen naturally increases the concentration gradient, decreases the concentration of oxygen on the inside, and causes O2 to diffuse into your cell. Once you use up the O2, all of a sudden there's a lot of CO2 on the inside, and it causes the CO2 to diffuse on the outside. What's interesting is even if you have a higher concentration on the left, but it is only of orange molecules of O2 and a lower concentration, CO2 on the right, they will try to equal out between orange and purple. That's why diffusion of different substances is possible. Alright, water is so important that we need to talk about it by itself. And diffusion of osmosis, or diffusion of water, is called osmosis. Osmosis is just the diffusion of water. The cell membrane is permeable to water, so water can fit through, but not substances like sodium ions. So if we have a high concentration of sodium, say here's our plasma membrane, high concentration of these particles, and there's sodium ions, low concentration of sodium in here, how does we balance that out? Well, this membrane is permeable to water. And if there's a high concentration of sodium on the outside, there's also a low concentration of water. If there's a low concentration of sodium on the inside, there's a high concentration of water. Water can get through, water can move. So water is going to diffuse from high to low concentrations and move out of the cell. Out of the cell. So, for example, if I had a semi-permeable membrane that did not allow sugar to pass through, we have a high concentration on this side, low concentration on this side. What could happen is sugar goes through the membrane. But what if sugar can't go through the membrane? You know what's going to happen instead? Water is going to move down on this side and up on this side. Water is going to, through osmosis, go over there, just like on this side. Dilute sugar on this side, low concentration, high concentration on this side. Water is going to move through the membrane from an area of high water concentration to low water concentration. Why is this an area of low water concentration? Because we have all those sugar molecules taking up room. Water is going to go over on that side, and actually we can build a potential difference in height because of a semi-permeable membrane. So, cells also usually differ in concentration from the solutions around it. And the tonicity of a solution is just the word we use to describe the concentration of a solution relative to the cell or an object, if we put like sugar cube, into that solution. So for example, if I put a cell into a solution that is more concentrated than that cell, we call that solution a hypertonic solution. If that solution is more concentrated than that cell, it's a hypertonic solution. If the solution is less concentrated than the cell, it's a hypotonic solution. And if the both cell and the solution have the same concentrations, it's an isotonic solution. We can make predictions about what happens to the cell if it's placed in one of these solutions. So for example, if I have a beaker of water, H2O, and it has a 0.5 molar NaCl concentration, and I put a cell in it that has a 1.0 molar NaCl concentration, water is going to move in this membrane of the cell, not permeable to NaCl. Water is going to move from the area of high concentration in the beaker into the cell, and it's going to cause the cell to blow up, to get bigger, to take on some water. And in plant cells, it could continue to take on that water until the cell wall pushes against the cell. In animal cells, it could do that until it bursts. If I take that same solution, but now it's 2.0 molar, take the same cell at 1 molar and put it into the solution, that's an hypertonic solution. If I put a cell in a hypertonic solution, water is going to start to move out of the cell, going from area of higher concentration, lower concentration, the cell is going to shrivel or plasmolyze, get smaller. In plant cells, plasma membrane is going to start peeling away from the cell wall. In isotonic solution, you don't get the net diffusion of water either direction. Is water going to move in and out of the membrane? Yes, but there won't be any net movement. It's not going to accumulate on either side. Very important, being able to predict what a cell will do if placed in a Important to know what will happen to a cell if it's placed in a hypotonic solution. Water is going to enter the cell. In a hypertonic solution, water is going to leave the cell. In isotonic solution, no net diffusion. Alright, lastly, how do those bigger substances that the cell needs, like glucose and some ions, get across the plasma membrane? Well, like we talked about before, it's those channel proteins, those gates, those integral proteins in the plasma membrane. Those channel proteins, those gates, can help molecules naturally diffuse into the cell where they naturally be too big to go through the plasma membrane through facilitated diffusion without using energy. Channel proteins or those carrier proteins like we talked that kind of bind to and then release the solute. Right. Look over that. Make sure you're confident about isotonic, hypertonic, hypotonic solutions, what will happen to the cell, and you understand osmosis and diffusion. That's it for next time. On Friday, we'll go over this and start our lab, but please let me know if you're confused.